media.
Today I want to talk about the Squeeze Theorem, and these are two people that came up with the Squeeze Theorem to approximate pi, Archimedes and Eudoxus. Johann Carl Friedrich Gauss is a man who perfected the Squeeze Theorem, and my two compatriots here will talk about the Squeeze Theorem in depth.
Are they from Ecuador too?
Alright, man. So the squeeze is based on three functions. So you have g of x, and so you have f of x and h of x. G of x is less than f of x, and h of x is greater than f of x. So f of x is like the middle function. G of x is smaller, and h of x is bigger than f of x. It's like in the middle. And they're gonna be continuous, so the limit as x of g of x goes to one point is the same as the limit as this function goes to one point. That's L. And if these two things are going to the same point, that means that the middle one, f of x, has to go to the same place that the two are going. It's pretty simple. They both go to L. All three of them.
Alright, ladies and gentlemen, this is where we get into the juicy stuff here. Now forget what that nerd said. Alright, let's say we have three graphs. We have 1 over x represented by here this line. We have g of x equals 0, which is represented here by this line. And we have 1 over x squared represented by this line here. Now what this really shows is that the limit as these go to, say, infinity, for example, here, it means that these will all...
You say to infinity.
To infinity. So no matter what the graph is, right, if it's smaller than this, or bigger than this, then it's going to go to the same exact thing. And this works not only for 1 over x squared, but 1 over any polynomial.
Jesus, that is great, man.
This means is that the Squeeze Theorem is not your one-trick pony. It is not the root test, which can only be used in specific situations where it's very annoying. You see, our product here is a jack of all trades, all right? If you use this today, you'll get 50% off on your next Chick-fil-A purchase too as well, so that's it. Thank you for watching.
Buenos dias, wey!
Shit!
So we're talking about Archimedes and Eudoxus. They use the Squeeze Theorem to approximate pi.
No, we're not going to be talking about them. We're talking about the Squeeze Theorem. This is one thing about the Squeeze Theorem.
Oh my god. You don't pay me enough to do this, man.